We broke down existing rock into pieces, sediment. So weathering, creating sediment. We took that sediment, deposited it someplace for that sediment to build up. And now that sediment is building up, we can now start the process where we turn sediment into sedimentary rocks. And that process is called lithification. It comes from the Greek word lithos, which means stone. It's the process by which you take loose sediment and transform it into sedimentary rock. And there's a 3-step process. 1, deposit sediment. 2, compact sediment. 3, cement together said compacted sediment. So that's typically how what do you call that? Sedimentary rocks are created. All right. So kind of a visual. The reason you need to compact it together, you can't just, if you just had a pile of dirt or a pile of sand and you left it there for a million years, it's probably not going to lithify. You need to compress it together. And the reason that happens, you lay down some sediment and then some more gets piled on top, some more gets piled on top, some more gets piled on top, some more gets piled on top. All that weight of the overlying sediment will kind of squish and apply pressure to the sediment below. So what happens is then all those little pieces of sediment get squished together. The pore space is reduced. Therefore, concentrating the water that may be in between those pore spaces into every single gap possible. As water is continue to be expelled because the pressure is getting more and more and more, and water kind of soaks out or kind of gets pressed out due to pressure, it's leaving behind some natural ions, some natural molecules that may already be dissolved in it that act like a cement. So that pressure drives out the water. Some stuff that was dissolved in the water, different ions and molecules, get left behind as the water gets pushed out, and it cements all that stuff together. Just like we had different types of sediments, biologic, chemical, and clastic, we have different types of sedimentary rocks, biogenic, chemical, and clastic. Biogenic sedimentary rocks are primarily composed of plant and animal remains, and can include minerals created by organisms. Some common biogenic sedimentary rocks, by no means is this an extensive list, just a couple examples. Coquina, it's the lithification of like shell material, like oceanic shell creature material, a bunch of that stuff broken down, cemented together. Coal is actually a biogenic sedimentary rock. Coal is the lithification of plant-rich sediment, a lot of organic material. So, these are just a couple examples. So coquina, you can see all the little shell pieces that have been cemented together. Sometimes people say it looks like a Rice Krispie treat. And then coal, there's different types of coal. For the most part, the more common types of coal are organic material that plants, leaves, trees, dead material that fall in typically a swamp millions of years ago. And that material, that organic material, piles up. It's biogenic sediment. It piles up, and the overlying pressure of the additional material on top compresses, compacts the material together, cements it together, and you get coal. The reason coal burns is because it's organic. Just like when you throw wood on a fire, well, the reason coal burns is because it's organic. It's living material, like wood. So those are just some examples of biogenic sedimentary rocks. Chemical sedimentary rocks result from the lithification of chemical sediments, which are typically formed by evaporation or precipitation. Some common chemical sedimentary rocks, again, by no means is this an extensive list, rock gypsum, rock salt, and limestone. You might be saying, well, isn't gypsum and salt, weren't those minerals? Yes. But you take those minerals, you dissolve it, that naturally occur, you dissolve it in water, transport that material somewhere. Now you have dissolved minerals of salt. The water evaporates away, and those dissolved minerals of salt, now sediment, pile up and create rock salt. So, a tricky little thing. Same with gypsum. Now limestone is a little bit different. So limestone, sometimes it can be considered chemical, sometimes it can be considered biogenic, because limestone is often made up of calcium carbonate. It's this molecule that gets created organically. So think coral reefs. In the coral of the coral reefs, their home, they're those hard shells are made up of calcium carbonate, among some other things. But as those pieces are kind of broken down, whether wave action or just naturally just disintegrating, that calcium carbonate get mixed with the ocean water and then eventually kind of settles out, precipitates out as it builds up, forming the sediment, and then the sediment getting created, turning into a sedimentary rock, in this case, limestone. So it's like it's 2 steps removed from biologic. So sometimes it's biologic, sometimes it's chemical. But limestone, rock gypsum, just some examples. By no means is this an extensive list. And then clastic sedimentary rocks, probably the most common type of sedimentary rocks, what we typically think of once we understand and are looking at sedimentary rocks. And this results from the lithification of clastic sediment, more so rock fragments. Oftentimes you can see and feel the pieces, they're kind of gritty, or you can see the different pieces that have been cemented together. Some common clastic sedimentary rocks, and we'll look at these in lab, include conglomerates, which are typically large, round, gravel-sized clasts that have been cemented together. Breccias, pronounced multiple ways, breccias I've heard too, is instead of rounded gravel-sized clasts, they're more sharp-angled pieces. They have more sharp angles to them, and that stuff's been cemented together. But those are made of the biggest gravel-sized clastic classifications. The next step down is sand. So when you take sand and lithify it, you get sandstone, and it feels gritty like sandpaper, dominated by quartz mineral sand grains. So it also often has like a whitish, yellowish, lighter color. Mudstone, a little less gritty. It's made up of smaller silt-sized pieces, or even into the clay-sized pieces. Sometimes it can be a little lumpy, but it's less gritty than sandstone. But if you really want to test its grittiness, you take a mudstone, just throw it in your mouth, grind your teeth on it. You'll feel the grit. You can't feel it with your hand. You can feel it with your teeth. Been there, done that. And then shale. It's the least gritty, clay-sized clastic sediments that have been lithified. Oftentimes shale looks layered. It feels somewhat smooth, but again, if you throw it in your mouth and grind your teeth on it, I got the shivers just thinking about it. Oh, you can feel it. So, just a couple pictures and examples. I don't want to give you too much, but conglomerate, round-sized pieces cemented together. So you can see for the most part they're mostly round. Some angled ones, but for the most part these are kind of rounded pieces that have been that you can see, gravel-sized pieces cemented together. It's a conglomerate. And then here you have a sandstone. You can almost feel the grittiness. You can almost see the sand in here. It's been cemented together to create sandstone. So that's just a little bit on taking sediment, turning it into sedimentary rocks. So each of these tell a story. So it's one thing to identify them, but they can tell a story about environments and the formation and how these formed and the environment of which the sediment was and how they formed. So they do tell a good story about the history of the earth. They tell a great story. There's just not much to look at least for me. They're just kind of earthy tones and I like shiny and sparkly. That's just me. Metamorphic rocks, next unit, that's my jam. But in any case, don't want to give too much because we'll take some time in lab to identify these different rocks. So we're going to go ahead and pause here. And when we come back, we're going to look at one more section called sedimentary structures. Not only do the types of rocks help us to kind of recreate the environment on Earth in which these sediment was either broken down, deposited, or lithified. But sometimes within these sedimentary rocks are different structures, different patterns, different arrangements that further help us figure out the climate, the location of things on Earth, a number of different things about the history of Earth. Again, sedimentary rocks tell a great story. Not much to look at, but they tell a great story, and one of those stories involves these different structures. That's what I'll tell you about when we come back. See you in just a second.